This video discusses how to divide polynomials using long division. Let's start with some vocab. What you're dividing by is called the divisor, and it goes on the outside of our division problem. What you're dividing is called the dividend and goes underneath. And then lastly, your answer is called the quotient. I want to start by recalling how to do long division of whole numbers. One of the things I love the most about math is that the overarching principles don't change. So the way that we divide whole numbers is really the same process that we're going to use to divide polynomials. So let's think about how we would divide 1,234 by 5. We start by taking our divisor into the first portion of our dividend, right? We don't try to take 5 into the whole thing, we just try to take 5 into 12. 5 goes into 12 2 times, so that's the first part of our quotient. Then we take that 2 and we multiply it by the 5. So we take the first part of the quotient, multiply it by the divisor, and we get 10. We put that below. Next, we subtract the 10. Subtracting 10, we get 2, and then we bring down the next number, which gives us 23. And we repeat the process. Now we take 5 into 23. It goes 4 times. That's the next part of our quotient. We take 4 times 5, which is 20, put it underneath, subtract it, and bring down the next number. Now we're taking 5 into 34. 5 goes into 34 6 times, next number in our quotient. We multiply the 6 by 5. We get 30. We subtract, and we're left with 4. Now with whole numbers, we have options at this point. We could just say, okay, 4 is our remainder and write R4. That's not what we're going to do. We could add a decimal point and a bunch of zeros and then keep going. That's not going to be the choice we take either. Or the third option is we could take our remainder and put it over our divisor and make a mixed number. 3 different ways that we can handle the remainder. When dividing polynomials, we're going to opt for the third option. We're going to make a fraction out of our remainder. So here's our strategy for dividing polynomials using long division. You'll see it's the exact same thing that we just did. We're going to start by dividing the first term of the dividend by the first term of the divisor. That may be the only portion that's different, that we're only going to use the first term of the divisor and not the whole thing to get us started. This will give us the first term of the quotient. Then we're going to multiply the term of the quotient found in step 1 by the entire divisor. And then we put it underneath, just like we did with the 10 or the 20 or the 30. Then we're going to subtract the polynomial found in step 2 that we put underneath. Remember, when subtracting polynomials, it's important that you line your like terms up vertically, and we're going to distribute the negative. And you'll see that more clearly in our first example. Then you bring down the next term. You're going to repeat these steps until the divisor does not divide into the leftover dividend. You'll know that it doesn't divide into the leftover dividend when the degree of the divisor is greater than the degree of the leftover dividend. That will become our remainder, and we will rewrite it as a fraction next to our quotient. A couple notes. Since we're working with polynomials, it's very important that both the dividend and divisor are written in descending order. This will make sure that we have like terms lining up vertically. Also, you want to include placeholders for missing terms in both the dividend and the divisor. We'll put in placeholders using 0 and then whatever variable is missing. This will also ensure that we have like terms lining up vertically. And then any remainder should be written of the form plus put the remainder over the divisor. Let's divide 8x to the third plus 2x squared minus 7x minus 11 by 2x minus 1. The first thing I always do is look to see are both my dividend and divisor in descending order. Also, are there any terms missing, which would mean I would have to add in a placeholder. Both dividend and divisor are in descending order, and no variable is missing. I don't jump, for instance, from x to the third to x to the first, like if this was missing. So that means we're ready to divide. Our dividend goes underneath. And our divisor on the outside. Just like with division of whole numbers, we don't try to do the whole thing at once. We're going to divide the first term of the divisor into the first term of the dividend. There's two different ways that you can think about this. You can either ask yourself, what do you multiply 2x by to get 8x to the third? Or my personal preference is to think about it as division, 8x to the third divided by 2x. Either way you think about it, we'll get the same answer. 8x to the third divided by 2x gives us 4x squared. That's going to be the first term of my quotient. I want to line it up vertically with the x squared term in my dividend. Now that we have the first term of our quotient, we want to multiply it by the entire divisor. This is going to require distributing. 4x squared times 2x gives us 8x to the third. And 4x squared times negative 1, that's going to be minus 4x squared. Now we're ready to subtract. We need to subtract this whole thing. Because there's more than one term, it requires parentheses. So we're subtracting that whole thing. Remember when subtracting polynomials, you distribute in the negative and then it just becomes addition. So I'm going to distribute the negative in. I don't like to erase anything, so I like to write the new sign and then circle it. This way, if I make a mistake, it's easier for me to look through my work. Now that we've distributed our negative, we're ready to combine like terms down. 8x to the third minus 8x to the third falls out. That should happen every time. If it doesn't, you made a mistake in choosing either the first term of your quotient or in multiplying back. Then we have 2x squared plus 4x squared, which gives us 6x squared, and we bring down our next term. Now we're ready to repeat the process. We're going to divide the first term of our divisor into the first term of our new dividend. So 2x goes into 6x squared, 3x times. Since that's a positive 3, we're going to write plus 3x. Since it's a polynomial, we have to have either plus or minus signs in between every term. That's the second term of our quotient. Now we are going to multiply that term by our entire divisor. Again, it's going to require distributing. 3x times 2x is 6x squared. 3x times a negative 1 minus 3x. Now we subtract this whole thing. When subtracting polynomials, we distribute in the negative, and then we can just add down. 6x squared minus 6x squared falls out like it should. Negative 7x plus 3x is a negative 4x. And we bring down our next term. And we know that this is not our remainder yet because the degree of our leftover dividend is not smaller than the degree of our divisor. That's when we'll be at our remainder. So we're dividing the first term of our divisor into the first term of our new dividend. 2x going into negative 4x. That goes in negative 2 times. We're writing minus 2 is the third term of our quotient. Now we're going to multiply it back by the entire divisor. This involves distributing. Negative 2 times 2x, so negative 4x. Negative 2 times negative 1, positive 2. We're going to subtract this whole thing. Distributing in the negative, this becomes plus, this becomes minus, and now we can add down. Negative 4x plus 4x falls out like it should. Negative 11 minus 2, that's a negative 13. Negative 13 is a lesser degree than 2x minus 1. Therefore, this is our remainder. We want to write our remainder in fraction form. Since this is a polynomial, we need plus and minus signs in between each of our terms. So we're going to write plus, and then whatever the remainder is, over the divisor. Now you may be thinking that you wanted to put the minus sign in front of the fraction instead of the plus sign. You could, but when we get to more advanced examples, even the next one that we see, it gets tricky to put the negative in front of the fraction. So I recommend you just always put a plus sign in front of the fraction, and if your remainder is negative, then leave that negative in the numerator. Let's try another one. Let's divide 9x to the third plus 6x squared plus 2x plus 1. Let's divide that by 3x squared plus 2. We always start by making sure that our divisor and dividend are both in descending order, which they are. Then we want to look to see if any placeholders are necessary. In either the dividend or divisor, do we skip over a variable? We do, in the divisor. Notice that we go from x squared to a constant with no x to the first. This is going to require a placeholder. I'll write my dividend in first. And now my divisor. Since we're missing that linear term, I'm just going to write plus 0x in its place. That 0x has no value, since 0 times anything is just 0, and adding 0 doesn't affect anything. But this is going to ensure that we have like terms lining up vertically. We're going to divide the first term of our divisor into the first term of our dividend. (3x squared goes into 9x cubed. 3x times. 3x will be the first term of our quotient. I'm going to line it up vertically with the x's in my dividend. Now we need to multiply back. We're going to multiply our 3x by our entire divisor. This is going to require distributing. 3x times 3x squared gives us 9x to the third. 3x times 0x, well, technically it's just 0, but I want it to continue to serve its purpose as a placeholder, so I'm going to write plus 0x squared. And then 3x times 2 plus 6x. Now we want to subtract this whole thing. We distribute in our negative, and then we can just combine like terms. 9x to the third minus 9x to the third falls out like it should every time. 6x squared minus 0x squared gives us 6x squared. And a positive 2x minus 6x gives us a negative 4x. And we bring down our next term. You may be asking yourself, how do I know how many terms to bring down if there's more than one available? However many terms cancel out, like our x to the thirds canceled out, however many terms cancel out, that's how many terms you should bring down in this move. All right, we're ready to divide again. First term of our divisor into the first term of our new dividend. Three x squared goes into 6x squared, a positive 2 times. Now we're going to multiply that positive 2 by our entire divisor. 2 times 3x squared gives us 6x squared. 2 times 0x is 0, but again, I want it to continue to serve as a placeholder, so I'm going to write plus 0x, and 2 times 2, positive 4. We subtract this whole thing. To subtract, we'll distribute in our negative, and then we can combine our like terms. 6x squared minus 6x squared falls out. Negative 4x minus 0x is a negative 4x, and 1 minus 4 minus 3. Notice that what we have there, that negative 4x minus 3, is a lesser degree than our divisor, 3x squared. That tells us that this is our remainder. We're going to put our remainder into our quotient in fraction form. So we're going to write plus, and then our remainder over our divisor. You can either write the divisor with the placeholder or without the placeholder. There's no real need to include the placeholder, so I'm going to opt to not include the placeholder in my remainder. So this one's a great example to talk about putting the negative in front of the fraction. If we wanted to put the negative in front of the fraction, we would actually have to factor a negative out of the remainder. And that's the mistake that people usually make. People usually say, oh, I'm going to put the negative out in front and then leave it the remainder like this. And that is not correct. You would have to factor the negative out of the entire remainder, and it would look like this. More times than not, people make a mistake, so I just recommend that you leave the remainder as it is, put it in the numerator, always put a plus in front of that fraction.